Conditional probability. First, conditional probability. Okay, right. See on this. Okay, right. So on this conditional probability, example is 10 cards with numbers 1 to 10 are placed in a box and mixed up, and then one card is drawn randomly. Okay, right. So if it is known that the number on the drawn card is more than 3, so this event happened first. Okay, it is known that that happened first. Then the second event is this. Okay, even number. What is the probability that? So this is a even number. Okay, right. So how many cards are there? 10 cards with numbers 1 to 10. Right. So the first event, what is that? So number on the drawn card is more than 3. So then the number on the drawn card, okay, is more than 3. Right. See, what are the probability to this? Right. Okay. In this, that first thing is sample space. Sample space. How many cards are there? 1 to 10. So the experiment is taking one card. Okay. After mixing all the cards. That is. So in the sample space, the card may be 1 or 2 or 4, 5, 6, okay, 7, 8, 9, 10. Right. Okay. So E is the event. This is one event. So the number on the drawn card is more than 3. The number on the drawn card is more than 3. What are the favorable to this? So this is the sample space. Okay. 10 cards are there, they are with the numbers 1 to 10, they are mixed up and taking one card. That one card may be 1 with number 1, or it may be 2 or maybe 3, okay, like this. These are the possible. That card may have any one of these numbers. Okay, that means the possible outcomes are these only. Right. So in that event is the number on the drawn card is more than 3. More than 3. What are the possible outcomes or favorable outcomes to this event? What are the favorable outcomes to this event in the possible outcomes? Okay, right. More than 3. 4, 5, 6, 7, 8, 9, 10. Okay, right. Next, take another event. F is what? See, it is an even number. Even number. Right. So F denotes even number. Okay. So even number. Right. See, we are basing on the event, this S event. This is sample space. Okay. We are finding the probability based on this. Okay. So F is even number. Even number. What are these? Favorable to this? 2, 4, 6, 8, okay, 10. Right, good. Probability, okay. Then, see, we have, what is the required probability? Required probability is that what? What is the required probability? So, after happening of that event, so that event is E. After happening of E, what is the probability of F? After happening of E, what is the probability of F? This we have to find. Okay? Right. What is the probability rule? Probability of E intersection F or F intersection E. Okay? So intersection part, how many are there? Intersection part. Okay. So that we write here. Intersection. Okay. So 4, 6, 8, 10. 4, 6, 8, 10. 4, 6, 8, 10. This is intersection. Okay, call it 1. Then we find all the values. See what we require. P of E. What is the probability of E? Probability of E. So how many are there? 1, 2, 3, 4, 5, 6, 7. So 7 based on the sample space. Based on the sample space. Okay, conditional probability, that is shortcut is there. Okay, no problem. So we are finding based on the this event, sample space event. Right. So this is right. Next, find intersection. F intersection E. So intersection, how many are there elements? 4. 4 by 10. 4 by 10. Now substitute in 1. Substitute in 1. Right. So probability of F over E. That is E already happened. Okay. Right. So this as per this intersection probability is 4 by 10 and E probability is 7 by 10. That is 4 by 7. So this is the required probability. Right. Okay. See, this is based on the sample space. Based on the sample space. See, the shortcut method is based on the E. What is the probability of F? Based on E, depending on E. E is the base event. Actually, when we are finding the probability, so generally the base event is sample space. Depending on sample space, we can find probability. But here on the conditional probability, we also can find so base probability of F basing on the event E. So event E is there. Okay, event E. How many are favorable to F based on E? Okay, this is the E. So when this we can treat as a sample space here. Okay, so based on this event, what are the favorable to F? F is even number. So what are the favorable to F? So on E, 4, 6, 8, 10. How many are there? 4. 4. 4 okay, right? These are 4. 4. How many elements in E? 1, 2, 3, 7. So like this also we can find. This is the required probability. Okay. So generally when we are finding the probability, so the base event is sample space. Depending on that we are finding probability. But in conditional probability, based on the event which is happened previous, already happened. Based on that we can find the required probability of the event. Okay? Right. So this is shortcut lo eppudu computative use cheyalante gaani deentlo there is the experiment tossing a coin. So tossing a coin, if the coin shows head, okay, then toss it again. Coin shows head, toss it again. So in tossing a coin, we can get, okay, right. So suppose head. If a coin shows head, then what we have to do again? Toss it again. Toss it again. So if it shows head, toss it again. So toss it again, we can get tail or head. Okay. So if it shows tail, then what we have to do? Throw a die. Throw a die. So if you throw a die, then what we can get? 1, 2, 3, 4, 6. Okay, na? Right. So T1, T2, T3. So these are the outcomes. T4, T5, T6. Okay. So here the outcomes are HT. Okay. H. These are the outcomes here. Okay. Right. So first coin, here also coin. So here die. So this is the experiment. Okay. Right. So what we have to find, given that this is the first event happened, So there is at least one tail. There is at least one tail. At least one tail. Suppose take this E. Okay, whatever may be the event, right? So that E is E be the event. Yeah, there is at least one tail. There is at least one tail. Okay. So what are the favorable to this? At least one tail. One tail favorable to this. So here we write, right? So E equal to. So at least one tail. Here one tail. So all are at least one tail is there. So here also one tail is there. These are all favorable to this. This is T1, T2, T3, T4, T5, T6. Right. So at least one tail is our. Next, what is F? F we write. F is what? Greater than 4. A number shows greater than 4. A number shows greater than 4. Okay? T4, T5, T6. Number shows T4, T5, T6. Greater than 4. Right. Greater than 4. Okay? Number shows greater than 4. Okay. Write it. This event is number greater than 4. Greater than 4. So favorable to this. Okay. T5, T6. Okay, right. So how to find probabilities on this, right? See, this is the experiment. To get the first experiment, here two experiments are there. Two experiments, one after another. One after another. See, this is the first experiment. To get a head, when we toss a coin, to get a head is what is the probability? 1 by 2. 1 by 2. Okay? Right. So from here, to get either head or tail. So that is also from this experiment.
1 by 4.
So 1 by 2. To get this HT, so HT, to get this, that the probability is, the probability to get this is 1 by 4. 1 by 4. How it is 1 by 4? You think it? See, what we are doing, one coin tossing, again another coin tossing. So this can be treated as a tossing two coins simultaneously. Okay, now, out of 4 outcomes, this is only one outcome, therefore this is 1 by 4. Okay, this is happening 1 by 2, this is 1 by 2, therefore this is happening. So this is also HH. 1 by 4. So the probability to get HH is also 1 by 4. Right. So come to this. So here to get the probability tail 1 by 2. 1 by 2. From here
1 by
6. Individually 1 by 6. 1 by 6. But to get this event T1 1 by 12. How it is 1 by 12? That is important. So 1 by 12 of this probability. Okay. So 1 by 12. 1 by 12. All are having 1 by 12. Okay. 1 by 12. 1 by 12. How? See, the first event is tail. Tail. Okay. So when we get a tail, then we have to throw a die. Okay. T1, T2, T3, T4, all are there. How many are there? 6. But these are the favorable we required. But generally what will happen after this event, H1, H2, H3 is also there. But we need that. We don't want those. These are required. But actually when two experiments are going on, this will also happen. But H1, H2, H3, those are also happen, but we don't want that. Okay, so because of that, these are 12 events. In the 12 events, okay, 12 outcomes. So this is one outcome, therefore 1 by 12. Right, okay. Now come to this. Right, okay. What is the probability of to get this? What is the probability to get this? Okay, right. See here, probability of E. So probability of every event, because see HT. What is the probability of HT? 1 by 4. Probability of T1. T1, all are 1 by 12, 1 by 12, 1 by 12. So 1 by 12, how many times? 6 times. So 1 by 12 like this. So 1 by 4 plus 6 times 1 by 12. Okay, this is 1 by 4 plus 1 by 2. This is 3 by 4. So probability of E equal to this. Okay. So intersection, what are the intersection? P intersection F also required. Intersection T5, T6 only. T5, T6. T5, T6. Okay, right. So now we find, see what we have to, the formula is not written. Okay, we'll write it. See what we require. So after this event, a number greater than 4. Okay, the die shows conditional probability when the given that this is the first event happened. So there is a one tail. One tail is E. So after happening of this event, we have to find this. So probability of E, probability of intersection. Probability of E, right? This is okay. Next. See, what is the probability of E? E is already over. Next, probability of intersection. E intersection F. E intersection F, these two events. This, okay, the two outcomes are there. What is the probability of this? T5 probability is 1 by 12. T6 probability is also 1 by 12. So, 2 by, right, 1 by 6. Right. Now substitute in 1. So substitute in 1. We get probability of F by E equal to. So probability of E 3 by 4, 1 by 6, 1 by 6 into 4 by 3.
4 by
4. Okay. 2 times 2, 3 times 2, 2 by 9.